What's going on, guys? Today we're going to have a great conversation with Logan from Wolverine Dabs. And we're going to go a little bit through the story of the Plasmastatic and some of the upgrades, some of the things we've learned. So if you're interested in this topic, keep watching. Hi, everyone. Welcome to another episode of Triboelectric Tuesdays. Today, we're going to be talking to Logan from Wolverine Dabs. You can follow him on IG. Logan did the basic R&D for the device. So we had a concept, we had an idea, we had a prototype, and that first prototype was sent to him. And can you explain to us, can you describe to us, like, how did it pop in your head? What happened? Can you just narrate how that process went the first time you tried the machine and you were like, oh shit, this works?
Yeah, so 100%. The first time I tried the machine and I started utilizing it, it actually was pretty much instantaneous. We dropped the sift through the machine, it popped down, it fed through, and there's immediate separation onto the plates. So we were able to see very clearly that, something was at least happening. And it's as soon as we brushed those materials down and collected them into two separate containers. Once we had two separate containers, we could clearly see the color difference. We could clearly see that the negative plate was collecting contamination, green bits. That's what the naked eye could see, at least, it was almost, all green. While the other pile, on the other hand, was, it was more tan, a little more golden. And I could already tell instantaneously, like, okay, this machine has removed contaminants. It has isolated a section of it that is obviously higher purity. And as soon as we looked at those sections under the microscope, it's a no-brainer. There's basically all contamination under the negative plate. You have some stalks and everything. And of course, a few heads will get carried over with stalks that have not yet been able to detach, as will the positive plate. You'll get a few stalks attached to the heads that will carry over onto the positive plate. But the difference is substantial and the separation is immediate. So the very first time that I utilized the unit, I was really able to tell, like, oh, wow, this works. This is going to do something.
So we did our testing with hemp, number one, because I don't have a license here, and Florida is Florida. So it was all done with hemp. And there was this small stretch of window where it got extremely cold in Florida, where I could actually do testing because the humidity dropped so much that I had like 40 RH. And it was like a fluke. Like, there were all kinds of warnings where it was going to be extremely dry. So whatever, it's totally unnatural for Florida. So I had an inkling of the fundamentals and things were supposed to be sound, but until you try something, you really don't know how it works. And gosh, it was a little bit over a year ago now that this happened. I remember, at least for me, I was in Vermont with Justin Massey. And in fact, it was his birthday and we were at a pizzeria. And for me, it was a lot later than for you, but I guess it was like 8 or something like that. And I get these WhatsApp messages and I was like, no way. And I'm there with Justin. I'm like, bro, like, we did it. And he's like, what do you mean? Like, we did it. Like, look at this. And then you start sending pictures that I was just blown away. I was like, no, this guy's just messing with me. You know what I mean? It must be like his sifter. He's going to say, yeah, haha, just kidding. It doesn't work. You know what I mean? That kind of like, defeatist mentality type of thing, but I was just, once you start sending the pictures and I'm like, you for real? Like, are you serious? It took a while to sink in, but I was like, oh my God. And both Justin and I were just like, so like ecstatic about that whole situation. It was for me, it was super cool.
I knew it would surprise you too, because you sent me that equipment and I had a few speed bumps with getting it all set up. And so it took me a little longer than anticipated to get everything set up and actually tested and tried. And
yeah.
I'm very weird about how I do everything. So I like everything to be in the perfect setting when I'm going to go implement it. And so as soon as I tried it, honestly, I had it for so long before I even set it up and assembled it that it was kind of like in the back of my mind, like, well, this could work, this could be. I didn't realize how beneficial it was going to be and the difference that it was truly going to make in the end product. and how much time it cuts off. I even with my current machine, like I ended up actually moving it to another facility, utilizing it at another place, didn't have it with me while I was at my main facility. So I started doing some hand static again, and just for convenience sake. But as soon as I moved the machine back and I dropped the first set of material through, I was like, oh my goodness, I need to be doing this with everything. Just wasted like so many days just playing with hand static again, like just trying to mess around with it, and which it's a great tool, and I still use it to achieve 98,
Yeah.
90% purity. But man, the machine cuts hours and days, months off of what you need to do to get to your final product.
I think that's a great segue to go over a lot of the Q&As that we get. There's, of course, we're very familiar with the technology. I'm neck deep into all of it. So for me, it's very clear. All these things are very obvious, but we get a lot of questions from people. And so I kind of wanted to go over like some of the things that the common questions that people get. So like, can you run us through like really how hard it is to the actual pushing buttons and what the machine, the operation of the machine, like what does that look like? Because people they seem to be kind of unsure or concerned about the complexity of the device. I mean, some machines have 50 million buttons and the processes. And so like, what is the user experience like? Like, how does that work?
It is so simplistic. It's actually kind of silly. The hardest part about the entire piece of equipment is assembling it. Once it's assembled, that's the easiest machine to use. It's basically like three, four things. Like you turn on the power, you power up the plates. You have your sift loaded in there. You start your agitation. You start your vibration to start feeding it through, right? And then you open up your line to introduce air into the system to start cycling everything through, because it essentially operates as a closed loop system, right? So the sift's being fed through, it's being funneled up, it's going in a spiral, dropping down between the two plates. But that's it. You literally just power up the plates, you start the feed, you open up the airway, and you're good to go. You're off to the races.
The most memorable comments I got from someone, this was at MJ Biz, and some guy was like, simplicity in its design, like there isn't really much there. And that's a good thing, right? I mean, it's not complicated, but it does the function very well. So I really like that. I keep repeating that because I think it was really cool. What can and can't the machine do? A lot of people ask me like what do you put in the machine? You know what I mean? So
I've been asked, like, do you put trim in the machine? And I'm like, absolutely not. That's not what it's for. Like, so the machine primarily, the purpose of it is for processing keef or sift or water hash. It's not for making keef, sift, water hash, or any of that. It's for purifying your starting material, right? So if you have loose keef, if you have loose sift from water hash or loose dry sift, powder, nothing's been congealed or anything, you still have the ability to purify it and separate it. And by that, I mean remove contamination, such as little bits of biomass, little hairs, any type of speck that's in there. That's the primary use for me, is to remove those contamination bits. What will be happening is also with that contamination, some stalks will be removed with it. From there, you're left with heads and stalks primarily, maybe a few little bits of contamination. But what this machine does is it does a really good job of isolating and removing the contamination portion of everything. So if you're very aggressive with your keef, your dry sift, your water hash, however you have it, you're going to be able to remove the bits of biomass that are going to cause you more issues down the line and present chlorophyll into your rosins. All of that. This is what's going to isolate and remove that.
Yeah, so it's a remediation device, not an extraction device, right?
100%. 100%. It is. You use it to purify something that you've already.
Purification. There you go. Purification. I like that better. It's a purification device, not your primary extraction device. You have to have something that's already been extracted into a powder form. Fair enough.
Not
So
only are you purifying, you are still left with the bits of biomass after. They haven't been destroyed, they haven't gone anywhere, and you can still use it for your food grade processing if you so desire.
so I get what can you process in the machine? You know, is it just for like dry keef? I try to explain to
I mean,
everybody.
that's all you can really put through the machine is a sift or a keef, but it has to be loose. Like I was saying, it cannot be congealed whatsoever. So you could take dried water hash that is, you could put it through, a sieve and you could get it all fluffy and light, and that's what you would process through it, because you're trying to put through it heads, stalks, little bits of biomass. And by that I just mean contamination in your keef itself. So
Right, but
this machine you load with water hash, dry sift, or keef.
right, and it can be live, it can be, you know, dry, it can be from trim, it can be keef from trim, it can
It
be
can be
keef from whole flower, it can be yeah, fair enough.
Yeah, it can be anything. It can be the crudest of materials, and that's where this machine really shines, is that when you put something in there that was so crudely done, but the heads are still valuable. The heads haven't been damaged. It's the same quality of material. You were just more aggressive with it when you extracted it in the first place. This machine is going to aid you in all of that.
Next question is yields. So like everybody wants to know, if I put a kilo of keef in there, what am I going to get? What are my yields?
And I say this to every single person. It's 100% strain dependent. And it's all going to depend on how aggressive you were with extracting that material. If you were super aggressive and you have lots of little bits of plant matter in there, you might get a 50-50 separation. You might literally get 50-50, but it's going to be so drastic. You're going to have green, and then off-white, tan, gold, brown, whatever. But you're going to remove how aggressive you were with it. Now, for me, on average, when I'm doing something like I still shake my trim or I tumble my trim in a resonator. Um, if you do that and you're pretty light with it, not too aggressive, sometimes on average, from what I was seeing when I was looking at my numbers this morning, was anywhere from 15 to 25% is removed into the negative column, and you retain, that's if it's 20 to 30%, you're going to retain 70 to 80% on the positive end of things.
And that's from dry trim. That's what you mostly process?
Yeah, that's mostly what I process, but I have processed everything. I've done live resin material, I've dry sift, and I've done dry ice keef. Like I've done some pretty aggressive stuff through it.
Right on. And I made a video about that. I think it's episode 18, but I'll put a link below so you guys can kind of check out an average breakdown. But the point being is that the machine will separate those heads. If they're not there, your yield is going to be really low. But that if they are there, you're going to get that. So I think that's the lesson learned here, that if the trichomes are there, if the round glandular trichomes are there, you're going to get them. And so if you start from trim, some trim, they shake that out, and you got to be careful, because some of the stuff that if you're buying secondhand products, maybe they've already been extracted to a certain degree. They've already been tumbled sometimes, right? So if the trichomes are not there, you're not going to get them, but the yields really wildly vary. And the advice that I can give people is just take a 10x loop or whatever and just look at your product. You should loop it. And if there's no trichomes there, you're not going to get anything because there's nothing there. So when I go out into a field or something like that and people tell me it's going to wash well, like really, it's really simple. You grab a loop and you look at the bud. If there's a lot of round trichomes, you're good. If there are a bunch of sessile pointy bits, you're not. That's that simple.
Yeah. No, that's the funniest thing, is people need to look at their product a little bit more. So it's like when we can look at the pile with our naked eye, but you really need to get under the microscope and check it out and be like, what is my approximate ratio of heads to contamination or stalks, or what have you?
Next question I get is like, so what kind of prep work does your product need to go into the machine? We've already discussed the fact that you can't put in actual trim or actual flowers in there. But so I've got a powdered biomass of any kind. Like for example, in Morocco, they've got the whole banya, or I'm not sure how to pronounce it, but you know the beating they beat it on with a stick, and but it's a powdered product. You know what I mean? It's already a powdered product. So that sort of product can be put into the machine. But what sort of pre-processing do you recommend, from like sifting, sieving, freeze drying, etc., to get you to the plasma in the best case scenario?
You know, I actually think after using the machine, I was using the machine pretty aggressively last week, and I was putting in a bunch of different types of material, and the machine really shined when I put in the dirtiest material. When I did, like, before I even put it back through an 80, because normally we extract through a 60 mesh, then drop that material back through an 80 mesh. I just extracted it through the 60 mesh and I put it right through the Plasmastatic, and it removed almost everything I needed it to remove. Then I dropped it through the 80 one more time, and that removed a good amount more. But I think it's all about, filter, 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 use the Plasmastatic. But my recommendation now would be, as soon as you extract the material, put it right through the Plasmastatic, then do your filtering. If you're finding more and more stuff, then try to drop it back through the Plasmastatic. But the machine is not going to achieve 98, 99% pure heads unless you're putting something so pure that that's the only option for it to give you, right? But mostly you need to aid at the very end, right? There's a reason we still finish with our hands at the moment until, some other stuff starts coming out, but we still finish everything with our hands still because we're aiming for 98, 99% purity.
I think
we achieve 80 to 90.
Yeah, you told me this. I think that at the very beginning you told me this, that the rule of thumb was, and it made total sense to me, that if the strain was melty, basically if it was expensive, it was worth doing the manual labor because you can sell the product for a premium. So I always focus on the final product first, and then the SOP is towards that. So if I'm making a food grade product, I don't need to spend a lot of money or time, right? There's a diminishing return of reprocessing, or the machine also has a set capacity. You can't process infinite amounts through the machine. So you have to, measure your resources and allocate those where they're best suited. And so if I have a product that I can sell at a premium, it's worthwhile finishing to a 99%. If not, maybe pre-processing to get you to that 90, 95%, and how you get there just really depends on your actual product and your pre-processing. But I think that that's a good rule of thumb. How much is the product worth? What are you using it for? There's no point. If you're going to press for rosin, there's a
goal. So, and if
what's your goal?
Is some good rosin and everything, this machine could be the deciding factor between some batches being really good and some batches being mediocre, because you remove those chlorophyll bits, you're aiding in the color of your rosin. And I'm speaking specifically for live resin material.
Yeah, and then that's the whole point of rosin, right? You put hash in a bag to press it because the bag itself is a filter. If you've ever wondered what the hell is inside of a empty rosin puck, a bag, it's just the shells of the trichome, and then there's stalks in there, and then little bits of biomass that made it through the washing process, right? So that's what that is. So the plasma process is cool because it's doing the same process of filtering. However, it's doing it electrochemically because it's also based on the chemistry, and it can separate a stalk when a bag really can't separate a stalk from a trichome because it's just going through the geometric shape and the size. So those are the kind of things, but that, to my point, really focus on your product and adjust your SOP accordingly. The one thing I will say that I do get a lot of people that have some issues with is humidity of the actual product itself. And I see that when you don't temper your material correctly. Like, for example, if your material is in a freezer and it's really cold, it's keef and it's really cold, and you take that out into the atmosphere, that's kind of like pulling a beer out of the refrigerator. It's going to get condensation on it immediately. And so what that is that water molecule attached to your hash is going to discharge the electrical charge in the particle. So you'll never build a charge by doing that. Same thing if you're doing a cryo extraction. If you're not careful, you're going to have condensation in your hash. And when you put it into the machine, it's going to be really clumpy, not sandy. And then it's not going to charge very well or at all. And you're not going to get a separation. So those are kind of things that, you may need to freeze dry. You may not. It really depends on your operating conditions. So that's one thing I will say about that. I don't know if you have any more comments.
Yeah, no, definitely making sure your material is very dry, very loose, ready to go for the machine. Because as soon as you start drying in moisture, like you said, it'll start clumping. It won't flow through the machine. You're going to run into a lot of issues. So that's where, you could choose to put the machine into like a walk-in freezer environment, for example, and just make sure your humidity is sitting below 40. But if you don't do that, then you're able to you just need to make sure that your material's dry. It's just like how if you pull a jar of rosin or any hash out of the freezer and you wait for the jar to come to room temperature before you open it so that you avoid condensation from getting in your jar for your concentrate. It's the same exact thing. You're applying it to the concentrate that you're about to run.
Let's do like a quick Cliff Notes type SOP. Let's not drag into the weeds, but a Cliff Notes type SOP. I hope you know what Cliff Notes are. Of the actual SOP I have trim, for example, and I'm going to go all the way down to finished plasma process, not hands sifting. But what is the quick and dirty SOP for that process?
Yeah. So basically take trim, tumble, hand sieve, however you're going to do it to extract the initial keef, shake, tumble, whatever. You extract the keef from that machine. You take the keef, load the keef into the plasmastatic, turn the plasmastatic on, let the keef cycle through. It will separate into two fractions. As you harvest and collect, you'll end up with two different fractions. Done. That's it.
Boom. Simple. Love it. Simple. Fantastic. What else do I get?
More to it, but there really isn't anything to it. You get your from your trim. However you're going to get your keef from your trim, get your keef from it. Make sure it's dry. Run it through the system. The system's so basic, you literally just turn it on, hit go, off to the races.
What have we learned in the last year? You know what I mean? Like when we started to now, like what are some of the things that just pop in your head from what we thought then to what we think now? What have we learned?
Well, I'm trying to think for that one. Like we're kind of learning more and more how to collect more at one time, how to get larger separations much quicker, how to make it a little more seamless and just continuing to flow. It's the same technology though, and it's applying the same thing. We're just perfecting it more and more each day.
Yeah, for me, it's been like the SOP. I've seen people really try to dial down the SOP. I've realized how important just the whole everything is. It's not just the machine, it's the pre-processing. And so a lot of the problems that you have, they're all SOP related. So you notice the limits of the technology, but they're all influenced by what comes before it. And so for me, I think that's like the biggest learning thing where, everything seems to work wonders for this guy, but this guy has all of these problems. And the one common denominator is that what the machine is all the same. They're all the same, but it is their SOP. They're doing something different. And their
source material is, and then here's the other thing. Like I said at the start, it's all strain dependent. So when you have one strain that I could tumble one strain for the same amount of time, the same weight and everything that I tumble another strain, and one might be more prone to creating larger bits of biomass into the keef. One might be hairier, might be more prone to having hairs in the biomass. One might be, there's lots of different things that could go on. But the other thing is like, okay, is your material dry enough? So many different things, so many different strains. There's lots of different variables. But you just have to, at the end of the day, know, okay, the material needs to act like this before it goes through the system. As long as it does that, there's going to be separation.
Give us one tip on how to increase the purity that you get using the machine. Because the ranges that I've seen from as low as 80% heads, and I've seen in one pass all the way up to 95% heads in one pass. In your experience, give us one tip on how to increase your quality, your purity.
My biggest tip for doing that would be to take your material and to rub it on a 200 mesh or a 75 micron screen and try to aggressively push stalks through, because you need a manual separation of the stalk from the head in order to get a higher purity off the machine. Because when that machine is not going to separate a stalk from a head that is firmly attached to it unless the genetics allow like a loose neck trait or a weak neck trait that the head's already weak and willing to pop right off. The machine might do that because it's pulling it, but at the end of the day, you need to do some separate manual separation yourself before you run it through there to allow more of the stalks to flow to the negative plate and to allow more of just heads to flow to the positive plate.
And here's a little insider info on that. So we already have a prototype device specifically for this process, and we should be testing it at a friend's place in New York relatively soon. So those are some of the new products that are coming out maybe this year for MJ Biz, if not definitely for next year or even for NECAN. But yeah, that's definitely something to watch out for, and we're definitely working on that. I mean, I think we've got it pretty dialed down. So Logan, given that the SOP is so important, you know, when you buy a machine, if you just don't really know all of the tips and tricks to the process, what is the best way to flatten that learning curve? Like, what do you typically recommend people that reach out to you on how to hit the ground running, how to learn the process faster? Like, what can you recommend just for that?
Be in person, a consultation. So I'm available for consultations. I'll fly out to you. We'll do a whole lesson. We'll go over all of your material and we'll make that machine operate with your material, as long as we're doing everything proper to get the material to the point where it's able to run through the machine and be separated.
And I'll be one to say it that it may sound like a pitch, but I'm going to second what you're saying, because I tell this to many people. Anybody can make bubble hash. Really, anybody can. You don't need any kind of expensive equipment or anything like that. But to make full melt, it takes a lot of skill. And a lot of these things, they're tactile, they're visual. And so I can make a video. And we have a lot of videos here. And this is one of the reasons we're making this video. But it's not the same. When you have somebody that is narrating, that is explaining, that is giving you that tactile feel of what the material is supposed to feel like, look like, it really is the fastest way to learn how to get to an exceptional level of skill than doing it yourself. Of course, you can learn this all by yourself. Of course you can, but
100.
There's a learning curve. It takes time, and for me, time is money. So I'm gonna second with you on that you definitely should reach out and have somebody explain the process to you if you want to hit the ground running and just make fantastic products straight out the door. There's no shortcuts.
Basically, if you just want to figure it out and know exactly what you need to do for everything that you're going to put through that machine and how to do it, that's kind of where I come into play. But if you want to figure it all out and have an adventure with it, by all means, I just have many hours running the machine and putting proper product through it. So,
yeah, fair enough.
All right, Charles. So I got a question for you. Why do you send the machine in so many little bits and pieces?
Yeah. How long does it take you to assemble the machine? First of all, I mean, really.
Well, if I'm going quick and I'm trying to get it done, I'd say, solo about 4 or 5 hours. I can get it done. I do know people, however, who have not been able to complete it in that amount of time, and it takes several days to complete. So I I don't think it's extremely difficult. It definitely takes a couple of hours, but there are lots of little bits and pieces to it.
Yeah, look, I'll be honest with you. I do get that a lot. Um, I think we just recently posted a video of somebody actually assembling the machine, which the user manuals don't tend to be easy to follow along with it. People seem to like videos, and that's kind of like we're trying to make some videos for that process. But look, the deal is this: we ship to Africa. I mean, I'm going to, Katama, Morocco from Miami, right? And so if everything is assembled, you're going to be on a truck, then on a boat, then on a truck again, and then on a pickup truck so it just wouldn't make it there. Unfortunately, you're dealing with plastics and you're dealing with components that once installed, you know, they're sturdy, they're reliable, but they just don't travel well. And the worst thing that could happen is that you get to a place like Morocco and the darn thing's broken. Like I've got customers now in Australia, in South Africa, in Morocco, and wow, in so many countries now that not one machine's gotten there broken. So everything, if you look at the install video, everything is in labeled little bags, but that's the reason. It's because if you ship it assembled, it's not going to make it, and that's just going to be a bad experience where you actually have to wait for replacement parts to come in. And again, if you're in Morocco, that's not an
It
easy thing.
could be months away.
Yeah, unfortunately, but that's kind of why we do it.
All right, well that makes sense. So talking to some clients and friends, I'll get a little pushback like why are there so many new versions, or why do we keep seeing different evolutions of this machine? And I'm curious, what else do you got? What's coming out? Anything new?
Look, it's a fair question. It's a fair question. Um, every year we get a new iPhone, and we all want the new iPhone, and so that's a natural reaction. So for me to say yes, it's just the natural evolution of the machine would be a cheap shot because we are now at version 1.61. So we've gone through 6 iterations. 3 of those iterations have been commercial. The first 3 were betas. So, however, I'm not going to apologize for the fact that the pace of innovation is in leaps and bounds. That's the truth. We have such a large community now. We've even got a Discord channel where you can actually have conversations with the entire plasmastatic community. And so the pace of innovation is so rapid that I think that it would be, I guess I got fireworks going on in my head. So I think it would be a disservice to everyone, to the community in general, if I just said, well, I'm going to upset some people by not implementing the lessons learned. And so the reason there are so many iterations, that the pace of innovation is so fast, because we're learning so much. And I'm the kind of person where I want to be the best of the best. And as much as I can push the technology forward, I will do that. And I guess now we're at a point where I don't foresee, though maybe I'm wrong, but I don't foresee any huge shifts moving forward. However, there will be changes, but the pace of innovation will definitely be reduced. Now, here's the good thing. Pretty much everything that we've implemented can be retrofitted. So for those that have, a version 1.5 up to today, can upgrade most of this stuff. And including like the very first version, you have version 1.3. So even those machines, for the most part, can be upgraded. And so what leaps technologically have we developed in the meantime? So The plates themselves have gone through different iterations, from the geometric shape of them, the material, the size in general, to really find a sweet spot of what people actually process to find a geometric shape and size of a plate that makes sense. And then we found some things, like, for example, the version 1.6 had very long plates, making cleaning under the plates really kind of difficult. Yes, it can be done, but so we made a couple changes where we actually sacrificed the surface area, and the actual throughput of the machine is dependent on the surface area. So, geez, we're cutting down the surface area, but that adds a lot to it, right? So the plates are different. They're bigger now. They're a little bit smaller, so they're easier to clean. Um, the newest version 1.62 should release, we'll probably start manufacturing that for MJ BizCon. And so those plates, we're actually taking glass beads, and we are sandblasting and creating a special surface on the plates. Why? You've seen this. Sometimes some of this hash, it's it doesn't
It'll
it's
just roll.
it just rolls.
It'll
I've
just
got a
roll.
Hey, I've got a guy in New York, and he's like, there's something wrong with the machine. I can't get anything to stick to it. It just rolls. He changed the strain, and his mind was blown. He's like, I'm doing nothing different.
It's the
So
strain.
it's a strain. It's completely strain. And like, you can explain this to people.
Something that will always come back to this is you will experience different things on each plate depending on what you are running, what strain it is, what pheno it is. It's going to act different. It's not going to always be the same.
And so, if you've got a version 1.6 and your plates are too long, you can get the new plates that are a little bit shorter. You'll sacrifice that surface area, but you can get them. They're not expensive. And even the new textured surface beads, plates, you can get those as well. So that's fine. The other thing that happens by reducing, the reason we reduce the plates is we have a discharge electrode. So I met this guy. He actually reached out to me, German guy. Christoph, just wanted to holler out to my boy. I mean, this guy, that's what they do for a living, electrostatic stuff. And so this guy reached out to me, and he's like, "Hey, let's talk." And I'm like, "Yeah, whatever." I kind of put it off. But I met this guy. I saw him in Spanibus. I mean, this guy just, they've got a fantastic company in Germany. He put his entire company at my disposal. A ton of incredibly smart engineers with all types of patents that they know far more than I do. And so this guy's gone above and beyond to work with me to step up my game. And a lot of this has been where it's not so simple about saying physics say this, and our experience says that, so this is what's going to work, so just do this because you don't know what you're talking about, and so you should just be doing this. He's been very patient and explaining to me the physics and how things should be. And then we've actually tested things where some of the things that are supposed to work a certain way, they don't actually work. And I go back to him like, bro, that just didn't work. And even they are, I'm talking about some people they're really smart guys. They really are. And they're just kind of scratching their heads about why it doesn't work. But we've gone through this trial process, and we've got two just insane achievements from them. Number one, why the plates are shorter, is a discharge electrode. And mind you, all of these components that we're talking about, you can buy those now, you can upgrade. And so what the discharge electrode does, you know, not every particle as it rains down separates. For one reason or another, it is just too far from the electrode, it doesn't have enough charge, whatever. Well, the problem with this, once it reaches the bottom funnel, because it's electrically charged, it naturally wants to clump. That's a problem. So this was Christoph's idea, where he was like, why don't you just discharge a particle? I'm like, how do I do that? Well, it has to be under these specific conditions. And he did all the simulations and the modeling and all that. And he sent me samples, and boom, zero charge, zero clumping, zero problems. So your product can go around again and charge. I'm like, are we going to have a problem where it's not going to want to charge the second time around? It's like, no. Sure enough, no problem. Second time around, it charges and it separates. The second major technological achievement that honestly we still don't really understand why, but his power supplies based on the similar sine wave that we discovered are night and day. You should see the cake thickness that you're able to achieve with the German power supplies versus the ones that we make, that it's just night and day. I mean, it's incredible. I mean, it's like cutting into a cheesecake or something like that. It's just thick. It is a big fat patty.
Or to
So
it. That
you
just
know what I
makes
mean?
drool and get jealous. That's all I
I'm,
want right now are big, thick cakes just on the plates, like ready to
I'm,
go. That's
I'm
going to
telling you.
yield and throughput and everything. That's just going to increase it. It's already substantially phenomenal. I crushed through a couple of kilos the other night, just crushing through them, like massive separations real quick. I can't even imagine what I'm going to be able to do with that.
Yeah, and so, all of these things you can upgrade, or they're coming standard in the V2, which is the GMP, the steel machine. That's all standard in it. But in the acrylic version, it'll come standard. It'll come as an upgrade, or if you already have a machine, you can upgrade it. So we're still going to have your basic package to keep the cost of the machine down, but some of these things that are optional items, you can upgrade to it. The other thing following that whole discharge electrical properties thing, the funnel in the bottom is made of acrylic. And so what people have to realize is that materials affect the charge of the particle. So you can't just willy-nilly use any construction material that you want. It's not that simple. You have to be very selective in what you use because it changes the charge of the particle, and the particles do all kinds of funny things. So anyways, the bottom funnel is acrylic, and that creates a whole bunch of problems. Clumping. We already solved the clumping issue. So now we are changing as an upgrade, adding a funnel that is steel because it will not impact the particle charge, and it comes with a vibrator. And so there's a little button that you can push. And so if anything is stuck on that bottom funnel, or you can just leave the vibrators on. This is similar to what you saw in the V2 at the demo you guys did at the class, at the SIP sessions. And the material is going to flow. The second problem that the acrylic hopper created was there was a gap between your vibrating feeder and the hopper. And so you have a gush of air coming down, and it would come out sideways, and you'd have all kinds of hash blowing over. And so we tried a whole bunch of different skirts. It was not the most elegant option, however functional it was, but I don't like it. I don't like how it looked. So we're changing to a steel funnel where there is no longer a gap. So it's all a unibody funnel and hopper. And that way there is just an eighth of an inch gap from the actual vibrating feeder to the actual discharge hopper. And that's going to eliminate most of the contaminant, most of these things happening. So I think that's going to make everybody's life so much easier, increase their productivity because less clogging, more automation, it's going to be more self-sufficient. So there is that. Another issue that we've had with some people, especially when the hash is a little bit wetter, the diffuser, which is the thing that's on top of the device, that creates a laminar flow. So basically, the hash needs to rain down as slow as possible and needs to fall by its own gravity so that the plates can separate it. So on top, we use a device called the diffuser, which just creates a round stream of particles into a flat shape. The problem is that, again, if I could make that thing out of steel, I would, but you can't because the particles discharge. So it's made out of plastic. Well, this plastic creates its own problems. So we're adding a vibrator to that actual diffuser to prevent any kind of clumping, because it can and it will happen, especially with some of the stickier hash, whatever. But this is also going to just prevent any kind of clogging, making that diffuser work properly, because sometimes the aperture will close or it'll close from one side to the other, right? And that just lowers the quality of the separation. It creates all kinds of problems. So that's another simple thing that we're going to incorporate. So you're going to have the option of a little control panel where you're going to put your air regulator there, and then your vibrator for your bottom hopper and your diffuser. So that's an upgrade. That's something cool that people can get. That's just really going to help increase productivity. I think that's going to be cool. The other thing that we have coming on is a PLC. So you'll be able to upgrade the option to a PLC where you're going to have a little cabinet with a little screen that's going to tell you what is going on, from how much air you're pushing into the system to how dry and at what temperature the compressed air is at. Because what I've seen is that some people have a very dry room, but their compressed air is actually wet. And that in itself is what it's giving them the problem. But and they're like, yeah, but my room is 40% RH. I don't have, but they're not reading the actual air in their compressor. Their air in their compressor is wet, or the compressor is outside and the actual tank is super hot. I got a guy in a desert, that has problems, but it's because the air is too hot. So, anyways, there's going to be sensors inside the cabinet that'll be able to monitor all of these things and graphically show you what is going on. So you'll be able to follow along. And it incorporates all kinds of sensors, for example, in the door. So when you open the device, it shuts down the power. So you can't hurt yourself. I mean, I know that the power supplies, you can't hurt yourself because even though they're extremely high voltage, they're low amperage. However, as a safety thing, it's better to prevent all these kinds of things. So some of the MSOs have asked me for those sort of features that are just necessary for them. And yeah, absolutely, those can be added. We have a lock and everything, and the instructions tell you keep the doors locked and then turn the power supplies off when you're going to clean. But it can happen that you forget, and you're going to get a big giggle out of it. But for some of the larger companies, that is a thing. So they ask for that, and that's coming. And then, of course, we have a GMP version, the steel version. We did a prototype that you guys did the SIF sessions are on, but we actually have a CE certified version that's going to be both CGMP and EU GMP compliant, that the pharma grade facilities that are looking for GMP compliance, that they can jump on that. And then the final thing, which doesn't seem like it's going to be ready this year, but perhaps next year, is the belt. And so we're working on a continuous collection system where the particles are going to stick to a belt and then they'll be cleaned off automatically. So you never actually have to stop to clean the device. But there's technological challenges to that. Very well, because you're the one working on it. You are testing the prototype, but those are the kind of things that are coming. And most of the options that we spoke about, you can upgrade. So huge winded reply to your question, I understand, but I hope that answers it.
Yeah, it does. 100%. That's awesome. I look forward to trying and using all of these things.
Yeah, I think I've hit everything that comes to mind. I don't know if there's anything else that you think of that we should go over, but
That's pretty good. I mean, talked about pretty much everything, frequent questions that customers have, any issues with the machine, no false expectations of the machine, just open honesty about what it can and can't achieve and what it's best used for. I think it's great, everything that we went over.
Fantastic. Right on. Well, everyone, thanks for watching. Logan, thanks for having this conversation with me. And I just want to say thank you for all of the incredible work that you've done with us. And, we're really proud to be able to collaborate with you. Guys, thanks for watching. And stay tuned, because more than likely we're going to be doing the next demo in Bob Barrett Morocco with this man right here. Cross our fingers that it all materializes, but that's the game plan. All of you guys watching in Morocco, all my friends in Katama, reach out. Whoever wants to host us, we want to go out there. We want to have a blast. So, anyways, guys, thanks for watching. Cheers.